So good morning all of you TyBscPhysics student. We have to see here the subject which is the solid state physics, and we want to continue the second module which is X-ray diffraction and other characterization technique. Last of few 2 to 3 lectures we have to complete here the point of the X-ray diffraction, and in this lecture we want to interesting to start the point of the characterization technique. Or you have to know that idea. So characterization technique and why need we have to study here the characterization technique. So because of this characterization technique we have to analyze or understanding the structure of the atomic and molecule and the nature of the structure of atom and molecule of the chemical bonding, imperfections and impurity which is present in the material. So that's why this complete knowledge we having. So that's why we have to see here the different types of the spectroscopic and technique for the qualitative and quantitative analysis. And there are different types of the characterization technique which is considered as the conventional chemical method, that is spectrochemical method, fluorescence analysis method, mass spectroscopy, X-ray powder diffraction, diffractometry and thermal analysis technique, and also consider has the thermal gravimetric analysis, and that main characterization technique which is considered as the nuclear magnetic resonance spectroscopy, Mossbier spectroscopy, photoelectron spectroscopy, Raman spectroscopy, scanning electron microscopy, Auger electron spectroscopy, etc. So these are the different types of the characterization technique which is used to analyze the structure of the molecules or the atomic or the crystal structure. Okay. So for example, we have to consider here the sodium chloride which is introduced the flame of the Bunsen burner, and for this yellow color flame which is seen when this flame which is examined through the spectroscope of the using the grating. And we have to know that we have done in the practical also. So that sodium atom which is considered as a doublet of the wavelength 5890 angstrom unit, and second line wavelength which is considered as the 5896 angstrom unit which is observed, and by this it is the possible to identify the material by measuring the wavelength of the light and by measuring. So these are the qualitative analysis of the emission of the spectroscopy, and by measuring the intensities of the spectral line, and it is also possible to find the amount of the substance producing these lines. So this is the data of the quantitative analysis of the structure. So there are some of the conventional chemical method which is considered as the spectrochemical method, and this is the emission and absorption spectra of all atoms are characteristics and have been investigated. So this conventional chemical method consider as first method which is considered as the spectrochemical method, and in this spectrochemical method we have to study of the emission and absorption spectra that of all the atoms which are characteristics and have been investigated, and the wavelength as well as the intensity of the emission and absorption of the spectral line of the different atoms are also tabulated. So that means that given data which is the emission and absorption spectra of all atoms, that characteristics of the investigated, and that the wavelength of the intensities of the emission and absorption of the spectral line which is different atom are well tabulated, the major and minor constituent. So this is detected by the presence of their characteristics, emission and absorption of the spectral line, and comparing the intensity of the emission line of the sample with that of standard curve and it is possible to find the concentration of the impurity which is present in the sample. And this spectrochemical method, which is including the spectrochemical emission of the analysis, UV visible absorption spectroscopy, infrared absorption spectroscopy, these are the study which is in the spectrochemical method. Next method which is considered as the fluorescence and analysis method. So this fluorescence analysis method, which is considered as the radiation which is used to excite the fluorescence, called ultraviolet radiation, and gamma rays, accelerated particle of like electrons. So if we see whatever radiation which is incident of any atom or the molecule, so what happens there? So that if this radiation which is incident on this atom, for example atom which is going to the core shell or whatever shell, so that space of the electron which is excited or which is going to knock out, if this excited electron going in the upper shell and this lower shell which is vacancy which is produced there, and every atom which is the property we have to get the stabilized condition. So that's why again the excitation of this electron. So this the excitation of electron, the emission of the light or emission of the ray. So this the emission of the light, so that is considered as or that is emit of the radiation, and this phenomena which is considered as the luminescence, and this includes the fluorescence and phosphorescence. So which is if you the transition of the fluorescence which is not involve the change of the electron spin, and the phosphorescence which is the involve the change of the electron spin, or we have to know that the electron spin plus half and minus half, that depends on the orientation of the spin. So this is the quantum mechanical concept which is very interesting, but we have to see further next lecture or next quantum mechanics subject. Next spectroscopy which is considered as the mass spectroscopy, and this method which is very sensitive method for the trace element of analysis, and in this method the specimen under the investigation is ionized by an ion source, and the ion are accelerated by using the electric field, and this accelerated ion then are allowed to pass through the external magnetic field with the separate of the different masses. So this is also very useful method to analysis of the characterization of the material for the ionize of the ion, and this ion which is accelerated the electric field and which is also passing through the external magnetic field, whatever observation we that conclude there. Next method which is considered as the X-ray powder diffractometry, and this an ideal crystal has perfect periodic arrangement of atom and molecules. However, in practice the actual crystal does not satisfy this requirement, to some atom and molecule of the material occupy the position and deviate the ideal arrangement, and this method of most of the commonly used as the characterize of the given material in regard their perfection of the X-ray diffraction technique or the field emission spectroscopy, electron microscopy, etc. Next method which is considered as the thermal analysis technique, and this thermal analysis technique which is considered as the one of the major method which is thermogravimetric analysis, that is TGA, from the analysis of the using of the help of the thermal data, and the details about the thermal stability compositional analysis can be this is obtained of the using the method of the analysis of the characterization, that is using the help of the specialized technique which is considered as the nuclear magnetic resonance spectroscopy, Mossberg spectroscopy, photoelectron spectroscopy, Raman spectroscopy, scanning electron microscopy, and Auger electron spectroscopy, etc. So this the new point which is starting here, the thermal, what is meant by the thermal gravimetric analysis, that is TGA. This is the very useful method of the characterization technique, and this thermal gravimetric analysis which is considered the thermal gravimetric analysis TGA is a method of the thermal analysis, and this method which is changes in the physical as well as the chemical properties of the material are measured as a function of the increasing temperature. So that is mean by, if you see that if we increasing the heat of the atom or molecule whatever, so what happens there, that disturbing this bonding of the molecule which is disturbing, or melting point of this which is disturbing, that is melting point means that the lattice all over the lattice structure which is also molecule or atom which is disturbed, and for this increasing the temperature or as a function of time which is provide the information about the physical phenomena such as the second order phase transition, including the vaporization, sublimation, absorption, adsorption and desorption, and this is likewise the TGA which can provide the information about the chemical phenomena including the chemisorption, dissolution, and that is mean by the dehydration, decomposition and soil gas reaction of that is considered as the oxidation and reduction of this method. So that the gravimetric analysis which is considered as the oldest and accurate method of the tedious and the time consuming, and the final step of this method which is the wetting, the hence the name of the gravimetric analysis. So for to understanding this gravimetric analysis, so consider following example. So for consider as the sodium chloride, that is NaCl, which is treated with the soluble silver nitrate AgNO3. So if see this reaction, so that gives the white PPT of the silver chloride, that is AgCl according to equation, and down of this reaction in bracket that is given the mass S of this particular formula or particular molecular formula we have to given here masses, and that numbers of the bracket it is indicate the formula of the weight of the substance. So reaction takes place here, the NaCl plus AgNO3 is gives the NaNO3 that is sodium nitrate and AgCl that is the silver chloride, and this above reaction shows that if you see in the down place of the bracket of the AgCl that 143.337 which is the part of the weight of this AgCl, and which is always produced by the using the help of this sodium chloride which have the weight 58.448 parts of the weight of sodium chloride, and when excess of this AgNO3 which is added to the NaCl solution. So for this solution NaCl which is treated of the excess of this AgNO3 which is take place in the reaction, so this gives the PPT of the AgCl. When the PPT which is washed in the dried, its mass was found to be 0.2500 gram, and calculate the weight of NaCl in the given solution. And this weight of the proportion of given NaCl solution or AgCl which is given in indicate that reaction which is produced by the 58.448 of the gram weight of the NaCl, and therefore this weight of AgCl which is 0.2500 of AgCl which have the produces the 0.1019 gram of the NaCl. So for analysis of this data, give the information of the thermogravimetric analysis, that is TGA, which is the temperature of a substance which is gradually increased, and its weight is noted the different temperature from the recorded data, and it is possible to know that what temperature as PPT is decomposing. So that is mean that if you give unit of this reaction, so that substance which is used, so whatever first method which is increase the temperature, and if we increase the temperature, so what is the information give about the weight of its, and what is the recorded data, what is the changing of this material, so that have recording. And this gravimetric analysis can be well understanding from the following example which is given here. The temperature which is increased the or heated the calcium oxalate which is 475 degrees Celsius, and this temperature which is increase the temperature, the PPT which is rapidly decrease, and this is because the temperature 455 degrees Celsius, and that whatever composing is there, so which is using by this using this thermal gravimetric technique. So according to this system, that is typical gravimetric system, which is considered as the weight of substance which is an environment which is heated or cooled and controlled rate at recorded of the time. So in figure A, this is the system of the this characterization technique, and figure B, which is show the graphical nature of the thermal gravimetric analysis curve of the polymer. On x-axis, here the C of the temperature range is given on x-axis, and y-axis which is given and the weight percentage. If you see that further the increasing the ratio of the temperature, so that also whatever what is the difference in the or what is change in the weight, which is also here. If we see this graph as considered as CaCO3, fiberglass, terrain, polyester. So what is the change if we increase the temperature, so as the characteristics of the graph which is decrease in weight. And for this analysis of the thermal gravimetric analysis instrument, which is shown in this figure, so that is the continuously weight of sample, it is heated to the temperature which is considered up to the 2000 degrees Celsius, and coupling with FTIR and mass spectroscopy gas analysis. As the temperature increases, the various component of the sample which is decomposed of the weight with percentage, and resulting mass change can be measured. So already we have to say here, so you have to know that property of the atom or molecule or any material, if we increase the temperature, so that such property which is changing, and this TGA instrument can be temperature which is calibrated with the melting point standard of Curie point of the ferromagnetic material such as ferrous and Ni, that is neon, and a ferromagnetic material which is considered as Ni, which is considered as the nickel, and that sample of the pan which is the magnetic field, and standard which is heated with the Curie point of the material, so paramagnetic which is nullifies, and it apparent weight change effect of the magnetic field. So that is also see that if we heating the material, that is changes of the magnetic property considered as the ferromagnetic, paramagnetic and weak magnetic whatever property, this is also changes. So see that further information or study or understanding of this material. So what is the uses of this characterization technique which is considered here? So first of all, it is can be used to determine the temperature and weight change of decomposition reaction, and which is allow the quantitative composition of analysis, and it is used to the determine the water content in the sample. Second uses which is considered as it is the analysis of reaction with presence of air, oxygen and other reactive gases, and it can be used to measure the evaporation rate, such as the measure of the volatile emission and liquid mixture. It also allows the determination of the Curie temperature of the magnetic transition by measuring its temperature, and which is the force exerted by nearby the magnetic disappears heating the reappearing cooling. And it can be also used to the measure the weight of the fiberglass or inorganic materials of the in plastic, laminates, paints, primers, composition material, burning of the polymer resin, and this film material can be identified by the XPS and microscopy. So this is also used. It can be also used for the measure the film material added to some foods such as silica gels and titanium dioxide. It can determine the purity of the mineral, inorganic compound or organic material. It distinguishes the different mineral composition of the global board of the mineral types such as borax, boric acid and silica gels. So next point which is used here or see here, the spectroscopy, which is considered as the ultraviolet and visible absorption spectroscopy. For understanding the atomic and molecular structure, the nature of chemical bonding, bond length, etc., which is required through the knowledge of different types of the spectroscopic technique. And this spectroscopy, which is the measurement of the interpretation of the electromagnetic radiation absorbed, scattered or emission by atoms or the molecule science. So according to this quantum mechanics, that atom can exist only discrete potential energy level, and potential energy of an atom, which is depends on the electronic configuration of the transition of electron from fixed energy level to other fixed energy level. So because we have to know that atom have to depends on this discrete potential energy, which is the potential energy which is high or low, or kinetic energy, what is the position of kinetic energy, that depends on your state, which is the discrete potential energy or continuous. So that discrete energy, which is considered in according to quantum mechanics, and continuous state, which is considered in the classical mechanics. And this fixed energy level leads to the emission of absorption of radiation, which is discrete energy, and this frequency, which energy which is absorbed or emitted, the related to the energy levels involved in the transition, and is given by EF minus EI is equal to h nu. And the absorption of visible or ultraviolet radiation by an atomic and molecular species can be expressed the following equation: h nu plus m is given as the m star, and this m star is an electronically excited species. The lifetime of m star, the about the 10 to the power minus 8 to 10 to the power minus 9 second, and any several relaxation process can lead to the de-excitation of the m star. And this relaxation process involves the conversion of the excitation energy, which is the given by the equation help of m star is gives the m plus heat, and so that consider m star, which is considered as the electronically excited species, and other in the remaining same state. And this relaxation can also occur by the decomposition of this m star, and this relaxation involve also the re-emission of the radiation, which gives the process like the fluorescence and phosphorescence, which is gives the m star, it gives the m plus h nu. And this analytical absorption of the radiation of by some chemical species can be either qualitative or quantitative. And the absorption of the UV and visible radiation by the molecules, which is generally occur in one or more electronic absorption bands of the made up of the mainly closely packed district line. And this spectrum, which is arise due to the transition of electron from ground state to the one of the many vibrational energy state associated with the excited electronic state. So that spectra, which is coming from the vibrational energy as well as rotational energy, because of the that electron which is go from ground state to the excited state, that is jump from ground state to excited state, or de-excitation from higher state to the ground state. So that's why we have to use for this spectroscopy, which is give useful information for the ultraviolet and visible absorption spectroscopy. And it is found that the excitation of electrons from p and d orbital, for p orbital, which is considered as orbital angular momentum L is equal to 1, and for d is equal to 2. So that occurs have above 200 nanometer to 380 nanometer, and UV, this is considered as the UV region. And the main difference between the UV and visible method, which is that in the UV ions or atoms or molecules, which is absorb more energy for excitation, while in the visible region and in this short ultraviolet spectra, which is attributed to the process of in which the outer electrons of the atom, which is absorbed radiant energy and undergo transition to higher energy levels, and these electronic transition are quantized. The depends on the electronic structure. The absorber electronic spectra have the vibrational and rotational fine structure. So these are the detailed understanding the study of the method of various types of the characterization technique, conventional chemical method, as well as thermogravimetric analysis and ultraviolet and visible absorption spectroscopy. So consider C in the spectroscopy or the method or technique like as a thermal gravimetric analysis, that summary, which is increase the temperature. So whatever property changes which is recorded in the data sheet, and in this absorption ultraviolet and visible absorption spectroscopy, that if we that EF minus EF EI, that is the excitation of the molecule from lower ground state to the higher ground state, and we have emit the energy, and that which is recorded in this spectroscopy, whatever record that is using the recorded in data sheet, and that information we have to understanding the what type of the nature of this spectroscopy. So this is the information. Now next lecture we have to see here what is meant by the ultraviolet photo electron spectroscopy, and after that we have to see here the scanning electron microscopy. So thanking of you.